Hi everyone, welcome to Simplifying Rational Functions. This is Nicholas JMV and this is part 1. So today we're going to be talking about using our algebra scale to simplify a rational expression. We want it in simplest form, okay? So that means when the numerator and denominator have no common or like terms. Nothing's common. And when that happens, when something's down to the lowest terms, we call that being prime, like with like 13 or 7 or 3. Those are prime numbers. Nothing goes into them other than 1 in itself. So that's how we know a rational function. When a rational function is in simplest form, you consider that being prime. Okay, so the last thing, when you simplify these rational expressions, you must state the domain restrictions, okay? And that's all the way through. So let's go ahead and get started on a few examples, okay? So in example 1, we're going to simplify each rational expression. So here we have 20v squared over 16v. Now I'll go ahead and do a little bit of this out, but you don't have to go as far as I go out on this, okay? So I know that 20 is 4 times 5. Okay, and I know that v squared is just v times v. I could do that, okay? And I know that 16 is also just 4 times 4, and just 1v is just times v. So let's simplify and cancel out what we can cancel. I want to say it becomes 1, right? So 4 goes to itself once, 4 goes to itself once. This v and this v will become 1. So we're left with 5v over 4. Now you might say, hey, great, everything works here, but let's be careful. Way back at the beginning, the only thing x couldn't be, or excuse me, v, we can't have v be 0. So v cannot equal 0 here. That means v cannot equal 0 in our final answer because these things are equivalent. They must have the same domain. So there's our first answer. In the second example here, when we talked about something being prime, look at p plus 4. That is prime. You cannot simplify that anymore. The numerator is a quadratic. We're going to look for two numbers that multiply to be -8 and add to be +2. Okay, so let's go ahead and look at the numerator. We're going to have p plus 4 times p minus 2, that quantity. And that gives us a product of 8, a -8, and a sum of 2, all over p plus 4. Now let's look. In the very first part here, our asymptote would suggest that p cannot equal -4. That would make this 0. So I've simplified. Let's see what can be taken out. P plus 4 and p plus 4 is common, and we're just left with p minus 2, and that's something linear. Okay, but be careful. You also need to say that p still can't equal -4. So there's our final simplified solution there. Okay. All right, let's go on to example number 2. All right, so in example number 2, let's simplify each rational expression. Okay, so let's look here. On the left, we have 25n squared minus 20n all over 15n. Right now, I know that n cannot equal 0 because that would make the denominator 0. So let's start in the top. 25 and 20, they both have a common 5. N squared and n, let's take out the n. So we factor out the GCF, so we're left with 5n minus 4. I can just redistribute if I need to double check my answer. The denominator, I can break that up into 5 times 3 times n if I wanted to. So that way I can see that the 5 and 5 will become 1. This n and this n become 1. And so our final answer here is 5n minus 4 all over 3. And we know that n cannot equal 0. So whatever our domain restrictions are in the original, that needs to happen in the final answer. All right, in part B here, looks like we have two quadratics. So let's see if we can go ahead and factor both of them, okay? We need, in the first one, two numbers that multiply to be -54 and add to be -3. Well, that's going to be factors of -9 and +6, okay? In the denominator, two numbers that multiply to be negative 42 and add to be negative 1 are p minus 7 and p plus 6. So before I go any further, I know that p cannot equal 7 and p cannot equal negative 6 based on this. I'm going to go ahead now and simplify. P plus 6 is gone. They become 1. And I get p minus 9 over p minus 7. You can't cancel out the p and the p here because of the operations. P cannot equal 7 and p cannot equal negative 6. So we can't simplify the p's out there. That's all we get right here. Here's our final answer. All right, let's look at example 3. Okay, again, simplify each rational expression. Let's look here. The numerator is a difference of two squares, so that becomes x plus 1 times x minus 1. All divided by, let's factor out the 3. Look, 3x minus 3, take out the 3, and we're left with 3 over x minus 1. So looking at the denominator, right now I know that x cannot equal 1. But let's simplify. X minus 1, and we get x plus 1 over 3. And I know that x cannot equal 1. Our last example, this one's a challenge example, okay? So why don't we go ahead, I want you to pause and see if you can go ahead and do this one. I'm going to pause really quick and see if you can complete this one, and then when you think you got it, come back and check to see if your answer is correct. All right, so we're back. So this numerator, you can factor out an x. Okay, they have a common x there. There's 13, that's prime, so there's nothing else. I'm going to take out the x in the numerator, and I'm left with 7x squared plus 13x minus 24. And that's going to be divided by, in the denominator, I can factor out a 6. And I'm going to be left with x squared plus we're going to have 8x here, and then the last term is going to be 15, or minus 15, excuse me. Okay? So this is when you have to factor when your a value is other than 1. Okay? And I can encourage you to see my other videos. Here I'm not going to go ahead and try to refactor. Essentially what you're looking for here is, if I was going to do in blue here, the 7x squared, if I came up here, I would say, okay, two numbers that multiply to be 7 times 24. Okay, I'm looking for two numbers that multiply to be negative 168. Multiply to be negative 168, add to be 13, and I had 21 and 8. So it would be x plus 21, x minus 8 over 7 here to account for that. So my two factors are x plus 3 in the numerator and 7x minus 8 in the, well, 7x minus 8 also in the numerator. The denominator factors into being, I get x plus 3 times x plus 5 when I simplify that out. And so the plus 3 and the plus 3 cancel, okay? And we're going to be left with x times 7x minus 8 over 6 times x plus 5. Okay? And we know that here x cannot be negative 3 and x can't not be negative 5. Okay? And there's your final answer. So if you have any questions or comments on simplifying rational expressions, you can go ahead and type them below, and we'll see you next time.